if we're all ready, we can proceed. Is science built on faith, or is it not? The problem of induction, basically. We will introduce, if you're familiar with it, the Humean problem of induction, and we're going to discuss some, fixes, let's say, or solutions, or propositions to solve it, or something like that. Okay. On slide 2, just out of the door, just immediately, this is not a presentation on religion. Usually people take the word faith to denote religious belief. This is not what today is about. When I ask, is science built on religion? Built on faith, what I really mean is the attitude of belief, which is accepting the premise, and accepting the premise, not only accepting it, but accepting it without sufficient or any question mark evidence whatsoever. If you were here last time, we kind of discussed justification, and we touched on the idea that sometimes justification could be internal, or could be understood internally, or if it's externally, then it's internal in some organization. So whatever makes sense to you, essentially, what you accept as proof is kind of different. And that's why I have sufficient question mark. What is sufficient evidence? Who defines what that is? That's the deal. But in any event, this is what I'm talking about. We're asking the question whether scientific knowledge, because we couldn't define knowledge the other time. That was a problem. At least it was, a little bit hard to establish. So we will ask today whether it's taken for granted just like any other system of belief, or does it have something special, this science? Is there something very, interesting about it that makes it higher, or let's say more credible, or whatever, than all the other systems? I have on slide 2 a picture of the demon to remind us always of the demon of Descartes' demon, who's always trying to trick us. He's always looking to, cause problems and fool us. And even when you are making very, very basic, let's say, assertions like 2 + 3 = 5 or something like that, even those could have problems in them. So we're going to keep that in mind, this kind of skeptic attitude as we go along. So we have on slide 3 a picture of a flame. This flame is blue, and it is generated using one of those fancy Tesla coils, and then it's creating all those ionized gases and electrons. And this is how you create such a blue flame. Okay. The question is very simple here. Would you put your finger on such a flame, yes or no? Let's say a minute. So I'm gonna leave my my finger for 1 minute on that thing. So would you put your finger is the question, and I wouldn't. And there's this wooden stick that goes next to it. By the way, this is a plugin. If you attended John Mallinckrodt's room the other day on radiation, anything that looks bluish like this has much more energy than something that looks reddish. So those red flames we have, the blue ones are kind of hotter. So it's not a very good idea to put your finger there. That's what I'm guessing.
For a minute.
Yeah, definitely never. I wouldn't even go as Benjamin. Like Benjamin's like for a brief period. I wouldn't even do that. Let's watch this video. This video is by the Action Lab, and he did it. He's gonna try something crazy here. So let's see.
Okay, so what I'm doing here is I just have a stick that I've dipped in water, and I'm just going to hold it over the plasma and see if we can actually freeze the drop over the plasma. Now again, the reason I'm able to do this is because I'm still supplying the amount of voltage needed to ionize the helium, but I'm removing the thermal energy from the helium. So the helium atoms themselves are freezing cold, but the electrons that actually fly off the helium atoms are thousands of degrees hot. But they're so small compared to the size of helium atoms that they can't transfer their thermal energy. So we have a plasma that's actually cold, in fact freezing cold.
It's solid ice now, look at that.
Holy cow, it worked, look, it's turning into ice. This is freezing fire. That is so cool. Look at that, solid ice. There's ice on the end of there. It's frozen solid.
I mean, this is cool. This is a cool setup. This is a cool setup, I must admit. I lied. I already watched the video, of course. I did not tell you that there will be helium and it'll be cooled with dry ice, which is going to stop the burning from happening. What I really wanted to show here is you can't rely on previous experience. Fire is supposed to be this thing that we know 100%. Like we are really familiar with fire. So some historians even go, you know, humankind, civilization, right? That it has dawned. The first thing we've ever done, you know, that is so super and so evolved more than you know, our fellow creatures who share the planet with us is our control of fire, which they put around, let's say, 500,000 years ago, plus or minus. So we are very familiar with fire. Yet there's this fire over here. Well, fire between quotations. It looks like a fire. It should burn like a fire, but it freezes stuff. That's new. That's weird. That shouldn't happen. If you follow me on slide 4, this is exactly what we would be talking about. There are many types of arguments. There are many types of, let's say, strategies you can use to prove an idea. Amongst those is 3 very big, large types, okay? Type number 1 is deduction. And deduction we've been talking about for a lot now. Whenever I say, oh, this is logical, oh, this is whatever, I'm talking about deduction. And it goes always, you know, there's an accepted rule, and then it's a general, and then it goes to a specific example. That's how it works. So something like, if you follow me on slide 5, all cats like milk. Pixie is a cat, therefore Pixie likes milk. This is a deductive argument. What we kind of do on daily basis, and it's kind of what we do when we do science most of the time, is something else. We will call it induction. And this goes from, you know, accepting that all cats like milk, because you can always ask the question, well, how did you know? Right? How did you know that all cats are? Well, I watched this cat and the other one and the other one and the other one, and I did enough observations. And then I said, well, you know what? All those cats seem to have something in common. They all like milk. And so if there's Pixie, this cat that we haven't observed yet, Pixie likes milk as well. That's how induction goes. Deduction says, oh, we know that all cats like milk, and then this is one instance of cats, and this is how we know. Whereas induction is like, hey, hold up 1 second. How did we get access to all cats like milk exactly? We have not. And so what we need to do is, we need to observe individuals in the world and then generalize a rule, which then we can apply to a future observation. Notice next to the Pixie likes milk, there's a small asterisk. It's most probably. You know, we're not really sure about it. Abduction works in the same way, where you go and you infer the best possible explanation, which is also something we usually do when we're doing science. And so you go like, oh, the cats like milk. That's what we've observed. And Pixie's ball is, you know, the milk is gone there. So most probably, the cat drank the milk. Now, did we see it? Do we have any logical, deductive reason to believe so? No. We just assumed. And it's the best possible explanation. Best, you know, between quotations. I don't know what that means. You define what's best, right? We go back to that internal sort of justification business. And if you follow on slide 6, you can see that there's this division between the two kinds. Whereas induction and abduction, traditionally speaking, right, in the literature, people have assumed, okay, you know what? We know that these are not quite sure, not most probably 100%. It's the most probable case, right? It's just close enough. It's good enough. It's close enough. Deduction gives us 100% certified, sure knowledge. This is perfect. This is the best. I'm hoping that you've gathered by now that I don't personally believe this. but we're going to stay in the mainstream for now. So this is the real problem. So what we've done in that video, what's happening over there, is there's this flame that we've never observed before, and we've observed all other flames, and we've made an inductive claim that says, oh, this one burns as well, and it doesn't. And that's the problem we're trying to deal with. This is a classic problem in science, and we're going to talk more about the details of it and how it's going. Let me know, is there any other question, any concern, anything? Slide 7 is also what this presentation is not about. I've used the word induction on slide 6. I don't mean mathematical induction. If you don't know what that is, forget about it. If you know what that is, there's beef between Russell and Poincaré on this, and we might do a room on this in the future. Poincaré claims that this is, something magical, and he doesn't like mathematical induction. Really, he's not in favor of it. He finds the same problems that we were talking about. Whereas Russell says, "Oh, this is a deductive argument, but it's kind of hiding." In any event, we're not talking about that kind of induction. We're talking about induction, which is, again, you're observing instances in the world, and then those instances, what you do is you generalize a rule from them, from those observations. All right. Slide 8. David Hume, the British philosopher, is the first person to identify this problem. Particularly, very accurately, let's say. He's the first person to write about it very clearly. And his example goes like this. He says, if all observed instances of bread, of course, any other thing would work, so a particular appearance, has been nourishing, then the next bread that you will see, the next piece of bread, it will also be nourishing. It will also taste good. It will also be. Notice also that there's an asterisk on nourishing, because this is kind of a weaker version. Instead of saying all future breads you will see, will be nourishing, I'm just making a weaker claim. It's only the next one, just the next piece of bread, just the next one. And this is called projection. In any event, they are very close to each other. And the beef about the next one and the next one has to do with mathematical induction, which we said we're not going to go into. But this is the problem that Hume observes. We have no idea, absolutely no idea why that would be the case. How is it that we're jumping from observations we've made in the past to guesses of the future? This is the problem of induction. We have absolutely no guarantee that this will be the case. In fact, we have no idea. On slide 9, you will see one, let's say, summary of what Hume discusses in my own words.
Can I just say something really quick? So, like, Hume's not saying that we have no idea whether or not, like, we hit a pool ball, the pool ball is going to react as if it did the last, 1,000 times we've done it. He just says that we have no deductive demonstration of that fact. But you can still have, probabilistic accounts of, inductive generalizations, right? Like, he's okay. He's perfectly fine with that.
Yeah. He is fine with that. But and we will get to the probability something. There's an answer for that. You're absolutely right. However, the problem stays. His solution is kind of a pragmatic stance, where, you know what, this is the best we can do. And then he calls it the rational thing to do as well. But it doesn't answer the problem. And we will see many answers to this, and you will see how hard it is to tackle. The main question is, like, to imagine what would happen if you were the first person to see bread. So even if you make several observations, if you're the first person, to observe this, God created you, you're Adam, right? And you're observing this. You have no idea if it would be nourishing or not. It's like these cavemen who tested all the herbs for us, and now we know which ones taste good and are not poisonous. We have no idea. They all look the same. If you imagine, like, there's another civilization that visits us and they're wondering what's all this green stuff, they probably assume that there's only one kind of green stuff. It's just the green stuff. Whereas we have tens of thousands of names for these things. And we know what season and what flower and what they're good for, etc., etc., and what they taste like, which ones are poison. We'll know all that because we've tested it. We're assuming that whatever we've discovered about them in the past is extendable into the future. And you know, you can say, oh, it's most probably, yes, of course, but we will see a big problem with this, because on slide 10 the question is, what's the difference between scientific induction and just superstition? How is it that superstition works? Superstition is something along these lines. Every time I knock on this table, my neighbor comes in, knocking on the table, and the neighbor don't have anything to do with each other. But then I believe, because every time it's happening, you know, this is a nice correlation that is being established here. Or every time I sacrifice this goat, rain falls. And so I am very justified by induction, the same kind of scientific induction, so far, to believe that slaying goats causes rainfall. Why not? Or like in the example on slide 10, every time the fortune teller has predicted the future correctly, so far, so I am justified by induction to believe that the next time she'll get it right. What's stopping me? Nothing. It's the same kind of induction, which is a big problem for science, because science claims that it has some superiority over this superstition idea. You believe in fairy tales, you believe in horoscopes. Who are you? We are the scientific community. We have a scientific method. We generate facts and knowledge and etc. Well, it's all based on induction. And if it's that kind of induction, it's the same exact thing that generates everything else. Is the problem clear? Does anybody have anything here? Please, admins on stage, if you can help me, you know, bringing people up, etc. Answering people in text. It's way too fast for me to read and speak at the same time.
I have a quick question.
Yes, before we go, yes.
A person who's realized that their superstition is not true, then would probably not continue to believe that that superstition is true. And this is a form of inductive reasoning. And actually, some people have actually like gone as far as saying that superstition has been described as a byproduct of adaptive behavior. So I would think maladaptive behavior would rely and hold on to superstition, but adaptive behavior, once a person realizes that that is no longer true, then they would adapt and move forward.
I'm not sure if I should be talking a lot about this, because this takes us into somewhere else. But very quickly, to answer your question, two main things. Thing number one, I don't know if this is the case. But there are superstitions all around the world, and they continue to exist with us, and they promote survival as well. Quick example: whenever we're teaching someone to use a firearm, what do we tell them? We tell them, hey, assume always that your gun is loaded, even when you know for a fact, even when you check 10,000 times. Always assume your gun is loaded. That's a superstition. That's not true. Whenever you check that the gun is not loaded, it's not loaded, period. It's actually against the logic of induction itself, or the logic of basic observation, or whatever it is that you want to use as your basic method of knowledge. It's against it. It's against every fiber of it. However, we continue to do it. We always tell people who drive for the first time on the road, always assume that other people are bad drivers. Never rely on someone else's reflex. Rely on your own. But this is not true. We know that some people are good drivers, some people are bad drivers, some people are excellent drivers. Assuming that other people are bad drivers all the time is superstitious. It's just not the case. But we continue preaching it, we continue entertaining it, because it promotes survival. And so I'm not sure if survival or benefit or whatever it is that you want to control it, what you want to call it, can actually be controlled by this self-correcting mechanism. So some things, there are billions of people who worship one god somewhere, and billions who worship some other god somewhere else, and from the scientific perspective, they are equally, how should I say this politely, non-factual superstitions. But they continue. And so I'm not sure how much this changing your mind, with that, with something that has to do with benefit or survival. I'm not sure if this works all the time. That's the point.
I feel like we're making this distinct, or we're conflating like what you think is true versus like how you should behave. Like with the gun example, it's a good example. Like I can handle a gun, and if you ask me, is it loaded? I say no, but I'll still treat it like it's loaded. I still won't point it at my head. I still won't point it at you. And I can say why, like, well, do you think it's loaded? Like, no, I know it's not loaded. I've already checked twice, but I'll still treat it that way because I'm just like, I'm more concerned about my muscle memory and my habits.
Is it only about that though? Is it only about that? Is it only about this muscle memory? Because you can totally train your muscle memory to do something else.
I'm trying to build good habits, basically.
That's superstition.
And is that a superstition?
Well, yeah. You can say, wash your hands every 10 seconds, and that's a good habit because you don't know what happens, to your hands every 10 seconds, what you touch, etc. And if you use this soap rather than the other because this is holy soap, or you can add whatever you want to this, and this is you can't say it's not a healthy habit. It's just superstitious. It's too much.
Some behaviors seem to have high downside and no upside. Putting my hand through an unknown type of flame has no upside to me, whether it's going to cause no harm, or whether it's going to sever my hand, or whether it's going to make my hand slightly colder than it was before. I don't know what kind of flame it is, so I'm not going to touch it. Some flames I won't even look at. Right, like electrical arcs or something. So I think there seems to be a difference between what I know and what I'm willing to do. Seems like there's a difference there.
There's also maybe closer to the to more controversial aspect of it. Example of Pascal's wager. Basically, you can be an agnostic or an atheist and live as if, like there was some sort of deity, meaning like having some sort of social and moral norms that are aligned with the practicing religion, whatever it is, and then having a functional society or functioning in the society, but still not believing in it, so like or believing in karma or something like this, but at the same time having like a rational argument against it.
Just to clarify, it's a wager. So we cannot prove or disprove the existence of God, and therefore, since it cannot be proved nor disproved, someone who would gamble on the existence of God because of the consequences that might arise. This is the reason why it's called a wager.
No, I agree, and I don't want to make that a center point. I was just kind of trying to use it as a more example that is more controversial, but still in line with what Shamash was presenting, because I completely agree with him. Every time passing by rustling bushes and acting as if there was a tiger there has a higher and better probability of survival. But we know for sure that maybe 90% of the times there's no tiger in the bushes. They're just rustling because of the wind. But it will help us survive.
Yeah, and here the boundary between what is superstition, what is just faith taken for face value, and what is absolutely demonstrated, it's scientific knowledge. But the boundary here becomes very gray, and this is the catastrophe. This is not the catastrophe, but the problem that Hume is referring to. So, four answers we're going to talk about today to this problem. First one, on slide 11, if you're following with me. First position is called in the literature Analytic Justification, which just says rational behavior. You want to know what that is? It's exactly induction. You're asking me how to justify induction? Induction is the only rational thing. How can you imagine someone being rational without changing their beliefs about the world whenever they make new observations, without expecting that these observations will affect the future, or how your attitude towards nature, or your understanding of nature, let's say. If your observations are not participating at all, how can you get to rationality? How is you know what I mean? This is the definition of right. This is the most basic element of rationality. It's induction. Any supporters of this? I remember hearing something that sounds like this, but I don't remember who is it.
Yeah, that goes in line with what I was saying. So somebody who would hold on to like a superstition would be irrational, and somebody who would remove that superstition and continue with their inductive reasoning would be rational.
Let's let's tackle this. Let's tell you the very quick answer for this. This attempts to define rationality using induction. But what about someone not agreeing to that definition? Oh, you want to know what rationality is? Rationality, to be absolutely rational, it means to believe in Jereziah, the god. That's rationality. That doesn't work. That doesn't solve the problem at all. This is very far from, although we want this, like the intention is very good, to say, you want to know what rationality is, it's induction. But it doesn't really help solve our problem, which is convincing or proving or kind of, let's say, justifying, even weaker, right? Justifying the use of this method. Just saying, oh, this is what we understand by rationality. I don't think this appeals to all those people that don't. And what you will find is, and I keep going back to this point whenever we're talking, because human beings should not be rational all the time. This is an assumption that is too heavy. We will be so depressed if we are forced to be rational all the time. In fact, most of what we do is very far from being very, well based and well rationalized. We have fights all the time. We scream because screaming scares away, your opponents as if they are bears. We take shortcuts. We insult, as we discuss. We do all these things. I don't see why defining rationality is. You want to define rationality in a way. Let's define rationality in the most common way we do. Let's not define rationality in a very niche 2% of our time activity. Let's define it in terms of the 98%, which is completely nuts. So this doesn't cut it. Number two also tries to make a slick move. Says past success of induction should justify induction. Why do we use induction? Because it worked in the past. Because every time we used induction, we discovered something very useful about the world.
That's the pragmatic approach, right? It's basically saying, like, if something comes along that's better, they will adopt it. But for now, let's just stick with whatever works.
Very close, yes. It's like, but it works. It solves problems. This is how engineers, they stand and they do. How to make this. They make this particular movement with their hand. When you have your hand very very wide and you kind of shake it, it's like pi equals 3.
Good enough for me.
Right? Well, this is the definition of circular.
It's
Sorry?
pi, like basically saying up to like I don't know, like 10 or 15 digits. Like it's good enough. Okay, let's move.
Yeah, that's fine. I mean, I'm fine with 3, but saying pi equals 3, that's blasphemy. Or pi equals e equals 3. Whenever they see e, they put 3 as well, right? This is the definition of circular reasoning here. To justify induction with induction, so past success implies a general rule. In the case of induction, this is circular reasoning. You want to justify induction for me? Don't use induction. Use some other method. come up with some proof that is much more convincing. So number 1 doesn't cut it. Done. Number 2 doesn't cut it. Number 3 is the pragmatic stance, which says even without justification. So number 2 tries to justify induction with its past success. That's circular. Number 3 says even when we don't have access to a justification, we gave up. You know what? It works. What's the problem? It works. Well, it works until it doesn't. That's the hope. That's the basic problem that Hume is trying to show us. By induction, you can get so far. It works until it doesn't. How is that better than superstition again? Nothing. Superstition worked until it stopped working. So is the science a bunch of superstitions? If this is what you want, fine. But scientists hold that they have something better, so this doesn't cut it. So analytic justification doesn't work. Past success justifying induction is just reason. No, I mean circular. And number 3, pragmatic. Yeah, that doesn't cut it either. You're free to make the choice, but that doesn't cut it at all. That doesn't answer Hume question. Okay. Any question here before I move to number 4? Number 4 is the probability one. And I know that people are very fond of this one, so I'm going to spend a little bit more time discussing it. Any question about the first 3? Did he compare science to superstition? It's not me, I swear. I'm just transmitting messages here. I'm only the transmitter. So, number 4, the probabilistic approach. There is a big camp inside that camp, which is the Bayesian camp. I'm not going to go into Bayesian probability. Probably we'll make another room specifically about Bayesian probability. We will prove the formula, and then we will discuss how people are, in my opinion, overestimating its entailments or its meaning. It's a very basic result in probability. But what we will say now applies to Bayes and other systems of probability. So every time, what do I mean by probability? Every time we observe, we become a little bit more sure. We become surer of the result. So if I taste bread once, yeah, okay, I didn't die. That's fine. If I eat bread twice, this is good. This is fine. If I eat bread 10,000 times, I'm kind of sure now. I'm kind of sure that this is a go-to. That's what I'm gonna do. If I've been living 50 years on this planet, and every single day the sun rises, assuming that tomorrow there will be another sunrise, it's kind of sure now because I've seen it a lot. If I went fishing in a pond and I was successful every single time for 2 years now, today I'm gonna decide to go there as well. Like I have no reason to change. I'm a lot more sure. If someone asks me what's the best fishing spot, I'm gonna tell them about that part. Why not? Like I've observed it so many times. I'm pretty sure now what's gonna happen. This is the probabilistic approach. To answer this and to show the problems in it, we will explain something very quick in logic on slide 12. And again, I suggest that if you want to follow, you click on the link pinned on the top of the room so you can see what I'm writing. So slide 12, we will explain something that is called implication. Implication in logic, the relation P implies Q. What does it mean when I say P implies Q? An example If I become president, then I will build a wall. This is an implication relation. Becoming president implies a wall will be built. Now, how do we understand this statement? If I become president and I build a wall, did I lie? No. The condition was true. The conclusion was true. And so I did not lie, and it happened. So if the first part, we're going to call it P. P for, why am I not writing here? Okay. If this is P, and this is W for wall, if P is true and W is true, then P implies W is true. If you elect me as president and I manage to build a wall, then I have said the truth. I did not lie. Now, if I become president, if you elect me, and I did not build a wall, I'm lying. I am not being faithful. So if the condition is true, but the conclusion is false, then I have lied. The whole thing falls apart. I have made a promise that I cannot keep. Now, question for you. What happens when I'm not elected as president? So the condition is false.
And we don't know.
You get
So
the Kanye response of, I guess we'll never know.
Oh, we know. We can know here. Because if you don't elect me president, whether there's a wall or not is irrelevant to the truth of what I said. I said, if you elect me president, I'm going to build a wall, or I'm going to lower the taxes, or whatever. And then you haven't elected me president. Can you come to me and say, oh, you lied? Sorry, not to use that. You have said something false?
You can't
No.
you can't hold them accountable.
Hold them accountable when they're not elected?
Yeah, that's correct.
I thought you were asking, will a wall be built? And I was saying, you can't tell.
That's another question. If someone else could build the wall, it's totally irrelevant here. The only thing is the truth of the following statement. If I become president, then I will build a wall. When is it considered false, this statement? When I'm not elected, can you come to me and tell me you haven't built a wall, you're a bad man? I'm not elected. You haven't done my condition. If you give me $1 million, if you help me win $1 million, I'll give you half. Well, you didn't help me. So can you come to me and say, I want my half? No. Whether I want the $1 million or not is a totally irrelevant issue. I said, if you help me, right? So the only way this implication is false is if the condition is true and the conclusion is false. That's the only way you can hold me accountable, quote unquote. You can say, oh, this is false. This wasn't a true statement. It's true every time else. When the condition is false, absolutely. Whatever happens is still within the boundaries. So if you flip to slide 13, I have copied the truth table over here for P implies W. And we will now check the other statement. Another statement is if a wall was never built, then I did not become president. So if I had P implies W, I have now not W implying not P. And we're going to check whether this is true or false, or when we're going to investigate. By the way, those tables we are doing here, they are called truth tables. Okay. So if you follow me with the writing here, not W, when is it true? It's the opposite of W. So whenever I see T, I'm going to write F. Whenever I see F, I'm going to write T. So I'm looking over here. Okay, this is F, I put T. This is T here, I'm going to put F. This is F, I'm going to put T. It's always the opposite. The negation of P, opposite to P, F, F, T, T. Now, we remember what we just learned about implication. If the condition, which is in this case negation of W, if the condition is false, then the whole premise is true no matter what. So I'm going to put the T on the first section here. If the condition is true and the implication is false, the conclusion is false, then I have lied, quote unquote. So that's false. If the condition is false, as we said, I'm looking at the third line, the whole thing is false. The whole thing is true. And if it's true, then it's true again. I'm only looking at the last three columns now. Okay. Now, we just filled it because this is how it works. I'm just following the rules here. And if you look at the last column that I'm encircling right now, and if you look at the third one that I'm also encircling, you will see that they are exactly the same thing. Whenever P implies W is true, not W implying not P is also true. And whenever it is false, the other one is also false. Which is why we say they are completely equivalent. They are the same. Saying, if it rains, then the streets are wet, is exactly the same thing as saying, if I see that the streets are not wet, it has not rained, for sure. Those are exactly the same statements. If it has rained, then the streets are wet. If the streets are not wet, then it cannot have rained. No way. P implies W, not W implies not P. They are the same exact thing. Any issues with this? Any questions? I know this is kind of whenever we do funny signs and and logic, people kind of get confused. Hopefully, the example I chose is simple enough. If you have anything, just let me know. I'm happy to repeat.
I think the thing that makes me the most uncomfortable is just kind of keeping straight that we're just talking about logical propositions and not lies, really. I mean, the point is, and this particular example is problematic because it's an if something happens, I will do in the future this thing. Is that true or not? It's not really a matter of truth. You're really saying that as a proposition, right? If I'm elected president, I will build a wall. And you just accept that. And then all of your decisions about truth tables, et cetera, is based on, analyzing those things. Is the statement true or false? And so especially when you start talking about the other way around, if a wall was not built, I did not become president. I'm thinking, it's once again, it's just because of that future thing. I'm thinking, well, maybe you just lied. If a wall was not built, what do you mean I did not become president? Maybe you just lied. But we really need to exclude the lying thing and accept the premise, which is that, if you become president, you will build a wall.
What this example or any other example is attempting to show is not the intention of the person. I don't know what their intentions are. This is not probably it's confusing because it's a politician and I tried to make a joke and it didn't work.
I think the rain example is just better because
okay.
Then it's in the past. You can really, it's not a matter of whether somebody's lying. You don't have to fold that into your considerations.
But this is not the problem, John. I can always take it to the future. If the streets, if it has rained, then the streets will be wet. If the streets are wet tomorrow, can you conclude that it has rained? No, not necessarily. But if they are not wet tomorrow, you can conclude that it hasn't rained, neither tomorrow nor today. Nor, you can take it into, let's say, a year from now. If a year from now the streets are not wet, I know for sure that it hasn't rained. You know what I mean?
You're right. It's just the injection of a person making a promise. That's what makes it difficult.
If that person was never elected president, then I cannot say anything to them. That's my point. They have made a statement. Sorry.
Oh no, I was just gonna quickly clarify. We're not talking about mental state of a person making a statement. We're talking about the statement itself, just its syntax and its semantics. That's it.
That's my intention anyway. So if you like the raining and the streets better, go for it. But it's the same exact thing, I promise you. So now that we've established this rule, we're going to give it a name on slide 14, and this will be what logicians called modus tollens. Modus tollens. Whenever I have P implies Q, and I have that the conclusion is negated, I can immediately entail. You can see the entailment relation here. I can immediately entail that the condition was false. This is allowed. We've seen modus ponens before. Whenever you have the implication and the conclusion is happening, then you will find that the conclusion happens. If true, then true. This is the last row on slide 14. No, here if I have that Q did not happen, so the conclusion did not happen, then I can conclude that P did not happen. If the whole statement is true, we are taking the whole implication as true here. So those two propositions are equivalent. Why am I making a big fuss about this? I'm making a big fuss about this because on slide 15, the fans of probability, and remember what we're talking about. We're talking about justifying induction with probability. I become more and more sure of whatever I saw before if it repeats. Okay? This is Hample's problem. All ravens are black is an equivalent statement to all non-black things are not ravens. I'm on slide 15. All ravens are black is equivalent to all non-black things are not ravens. I have the funny logical writing of this just for you to believe that this is the case. If you like the English better, so be it. The funny math below it is not necessary if you're bothered by it. If I'm going to call the first part of this implication, all ravens are black, if we call it psi. And the second part, all non-black things are not ravens, we're going to call it phi. Every evidence of one, because they are equivalent, is an evidence for another. If I have A and B equivalent, evidence for A is evidence for B. Evidence for B is also evidence for A. They are equivalent. So every evidence of all ravens are black is also evidence of all non-black things are not ravens. We have to accept this. This is a fact. This is logical entailment. But if we do, this means a white shoe is evidence that ravens are black, or a white paper, or a green whatever, for that matter. Why? Because a white shoe fits the proposition all non-black things are not ravens. Is this object black? No, it's green. What is it? Is it a raven? No, it's a cup. So green cups are evidence that ravens are black now by induction. And the more you see green cups, if you like probability, the higher the probability is that all ravens are black. This is absolutely ridiculous. Nobody would accept this. You shouldn't. Not only this, but equivalently, a white shoe is not evidence only for ravens black. It could also be equivalently evidence for ravens being green, or any other color for that matter. Why? Because it's the same logical scheme. If I'm observing a yellow cup and I say this is not a raven, can I conclude that ravens are black? It could be any other color. I don't know. This is all by induction. That this is not acceptable. This is a huge disaster. This probabilistic approach is a huge disaster. We have to be very careful whenever again, all of these answers, the 4 answers we presented, they come from good intention. The intention that you want when you make such a claim or you hold such a belief, we kind of have an intuition of where you want to go. But the actual statement saying I will become more sure of something whenever I make more observations of it, even that statement is, there's a lot of details. What does it mean to have connections of correlation versus causation? That's another totally big problem that I'm not going to get into. But even when we take it face value like that, knowing that ravens are black has to do with ravens. I'm observing ravens. It should not be about observing any other thing. But it turns out that it could be taken like that. It could be interpreted like that. And I know that this example is ridiculous, and I've picked a ridiculous example on purpose. But you can pick examples that are not ridiculous, since you allow it in your theory. Observing flat papers is now evidence that the Earth is round. Why not? If I have a flat map, it's evidence that the Earth, or a round map, it's evidence that the Earth is flat. You can do whatever you want. This becomes very chaotic very quick. Does this make sense, or does anybody have a question? I will stop here and I will listen to you guys.
So it looks like you're about to move on to something else. Do you have, I mean, is it really just leave here? Hample's problem just basically, is as it is. There's no way kind of to narrow the range of inductive approaches to eliminate it and then make us all happy again.
There is. Probably we won't see it today. But listen, this topic is one of the hottest topic in the philosophy of science. So some exercises will have to be left for the reader at the end of today. It will get worse though. Hample's problem is not the worst thing that happened to probability theory. Slide 16. It gets worse. All ravens are black. All non-black things are not ravens. Now, I will ask you guys questions. I have a raven behind my back. Do you care to see it? By induction, do you care to see it? Yes or no? Does it matter?
So I feel the black swan fallacy coming up, but I'll say it's black, right?
No. I don't even know what color it is. I'm only asking. I have a raven behind my back. Do you care to see it? Yes or no? I'm not asking you to guess its color.
Oh yes, absolutely yes.
Of course, I want to see it. Why? Because if it were not black, it's a disaster, right? We've discovered that this rule that we've proved by induction is wrong now, because some of the ravens are not black. Okay, so if I have a raven behind my back, you want to see it. If I have a black thing behind my back, do you care to see it? Does it matter?
Might that black thing be a raven? Or are you saying
could
a
be.
non-raven black thing?
If it's a raven, that's okay. But if it's not a raven, does it hurt my conclusion? No, not at all. If I have a black pen behind my back, what does it matter? How can it improve my hypothesis? It doesn't. I said all ravens are black. I have a black thing behind my back, whether it's a raven or not, doesn't matter. So this guy here, number 2, is not relevant. A raven behind my back, number 1, is relevant because it could be a different color. But this one doesn't. Number 3, I have a shoe behind my back. Do you care to see it?
Doesn't matter.
If it's a shoe, it doesn't matter. You're absolutely right. Because I'm only care about ravens here. I have a shoe behind my back, I don't care. I'm talking about ravens here. But then when I say I have a white thing behind my back, then it absolutely matters. Why? Because that white thing can be a raven.
No, it can't. All ravens are black.
But then you will update your belief by probability, John. Come on.
But it took me. I mean, that's what it really did take me a while to understand what you were doing here, right? And now that I understand, once I finally understood what you're doing, I can go down the list really quickly and get them all. Yeah.
So the cool thing here, I think, to understand is that you are talking about the properties of a category, not about difference between categories. So once you lock yourself into a category, you're talking about its properties. Then the color or the shape or the size or whatever it is of raven matters. But if it's not a raven, then it doesn't really matter.
That's another problem with this. And Wissam pointed it out like 5 minutes ago in chat. What if the definition of raven doesn't include color? or the definition of raven only includes the color black. So whatever I produce from behind my back, completely identical to a raven, but is white, you say, oh, it's not a raven, right? It's a white raven. It's a different species. So we can play with semantics all day long. And whatever example I pick, we can play with semantics all day long, which between you and I adds even bigger catastrophes. Let's not get into that. What do we mean by a class of objects and we give them an identity? What is a raven? How do we know it? Oh, that's a much bigger problem that science has never went to, right? Science has never bothered about the problem of identity.
I love the Schwarzenegger accent, by the way.
Sorry?
I love the Schwarzenegger accent.
Schwarzenegger.
There's a problem.
I'm not sure if it's Schwarzenegger or something else. But... So disregarding that problem, that's what I mean. Disregarding the fact that we can play with semantics all day. If I show a white thing behind my back, you should care. Why? Because if it is a raven, it falsifies the claim. Notice what happened here. If you focus on 3 and 4. Let's focus on 3 and 4. I asked you, I have a shoe behind my back. You said, I don't want to see. Doesn't matter. I have a white thing behind my back. I should see. The shoe in number 3 could be white. And the white thing in number 4 could be a shoe. You don't know. And so if I told you I have a shoe that is white, you don't want to see. But if I tell you first, oh, I have a white thing, you're like, eh? Ah, it's a shoe. Ah, okay. So when I say white, then shoe, I have your attention. When I say shoe, then white, I don't have your attention. And that is complete bonkers. Because I supposed that a piece of evidence, right, a state of the affairs in the universe, should be seen by the scientific theory as the same thing. Whether it's relevant to the theory or not, it should be a matter of the thing itself. It should not be a matter of how I describe it and which order I use. If I say shoe white, it's irrelevant. If I say white shoe, then it's relevant. It turns out it is. So it's not only a disaster that white shoes add more justification to black ravens. That's already a problem big enough. Oh no, there's another big problem, that the order of words I use is now a big problem. If I give you one piece of information before the other, it really matters. And of course, we don't want that. Who in their right mind would want this problem in a theory? Again, this applies to Bayesian and all the others. Bayesian alone has a different set of issues with it. But this applies to every probabilistic approach. Every probability you can think of, we're updating whatever we have, truth values, valuation functions, whatever you want to pick, then it will have the same problems with it. This is Hample's induction problem. Questions? Anything else before? There's one more thing we're going to talk about, and then we finish.
So wait, a few minutes ago you said if you had a black thing that you're not interested in.
Yes,
but
I'm not.
I'm confused. Aren't you interested in a black thing?
No, I'm interested in ravens.
I mean a crow. I mean a raven.
Yeah. Okay. So let's go through it, Hiro. Let's go through it. I have a black thing behind my back. It could either be a raven, or it could not be a raven. Let's say it is a raven. Does it affect my hypothesis in any way? Not really.
Oh, I see. It just simply confirms it. It doesn't add any more information.
You can say you can go the Bayesian way and say it adds more confirmation to whatever you know already. Okay, very tiny, very little, because already supposedly you've made billions of observations to conclude that all ravens are black,
maybe
right?
I didn't realize that. What if it was the first? What if you haven't actually looked at a raven yet?
Then you have no idea. Then you should not say all ravens are black. You cannot start there.
Okay, I guess I'm confused what we're doing. We're trying to prove the statement all ravens are black?
I'm trying to see
it's the blackness. it's the blackness of the raven that's in question, not necessarily the raven black.
You're kind of in the matrix, Andre. Hero, we're only taking a very simple case here, just to show the mechanism of a theory that says whenever I make an observation, I'm updating. Okay, so this updating mechanism, how does it work? This is the only thing in question here. So if I say I have a black thing behind my back, it's very minutely, relevant, because if it's a raven, then fine, because we already know all ravens are black. And if it's not a raven, that's also fine, right? Because not only black ravens exist, black other things exist as well. But then, if I have a raven behind my back, and it turns out to be a different color, this destroys the entire validity of the claim all ravens are black. Again, disregarding the semantic issue of how do we define a raven, etc.
Okay, so if you're looking for exceptions, then seeing the black raven is not interesting.
Very little.
Is that what you mean?
So very littly interesting. Because you've already made 1,000 observations. 1,001 will increase your probability of surety, quote unquote, by 0.0001%, right? If you want to go down that route, if you want to. Some other theories might say, let's say, observing 1,000 instances of an experiment is fine. So 1,001 is not necessary. That's it. How many times do we have to do the Bell experiment? That's a popular topic here. Right? If you do it one more time, it doesn't really matter if it gives the same result.
But it matters if it's a pimply-faced 20-year-old.
Ah, yes, because of the pimples, absolutely. Is it okay, Hero? Is it a little bit clear now?
Yeah, I guess I was just unclear on the motivation, but I feel better now.
Great. So this is the disaster with Hample. The order of the information matters, and we don't want that. This is absolutely no way helpful. But another big problem is what we call Goodman's induction problem, and this will be the last thing we talk about today. So there's Hume's, and then there's Goodman's. There's Hample's, which said, oh, you know what? There's more into here. This probability sort of thing, it has problems. And Goodman's induction problem even bets higher, because Goodman, being let's say, I don't know, 250 years later than Hume, he even raises the bets. He raises the stakes. For him, the problem of Hume can be even made worse. The way he can make it worse is in the following example, and I will repeat exactly his example. It involves some trickery though, so if it's a little bit tricky, if you just stay with me and then take it slowly, I'll try to explain it in the best way as possible. You will follow the text on slide 17. So here's Goodman's example. He says an object is GRU. We're going to define a new property now. We're going to create something new. What is this new thing? It's GRU. What does it mean to be GRU? It means you are green before New Year's Eve and 2025. We are today 11/12. So we are before. Being green before New Year's Eve is called GRU, as long as you change afterwards. So let's say I have a car. It's green now. New Year's Eve, I paint it blue. I can say this is GRU because it has changed the color after New Year's Eve. We can pick any other time, by the way. Time t, right? So something being green before New Year's Eve and being blue after New Year's Eve, this is the new property called GRU. Now, I'm observing a bunch of weird emeralds today. They've fallen from space, and I want to see what they're about. A huge quantity of them has fallen, a big meteor. And I'm observing all of them one by one, and I say, wait, they're all green. But I can also say they are all GRU. Why? Because being green before New Year's Eve qualifies as GRU. So Hume's problem stops here. Hume's problem says observing a few emeralds without seeing all of them and generalizing to saying all emeralds are green, or the next emerald I'm going to say is green, that's a problem. Goodman takes it a step further. He says you can take it into two different senses. You can define this new thing called GRU, which changes in the future. And you can say that observing a bunch of green emeralds today could be taken as evidence that they will change color in the future. But this is a disaster.
I guess I don't follow that. I
Okay.
mean, it seems to me, I mean, I'm just looking at that and saying, well, first of all, that is the question, I suppose, of whether an object has to be either green or GRU. I
It
think,
doesn't.
you know,
That's exactly what the problem is. It could be both.
yeah,
We have
right.
no
So
idea.
that's part of the problem. But the other problem is I don't see how you could possibly have, you know, say that observing something that's green today. Yeah, I mean, I see the problem here, but it strikes me you have no evidence for GRU until you have some evidence that something changed, right? You have to have at least, yeah, it has to at least be in the past that you have seen that object be green and
Well,
then be blue afterwards. But I
well,
mean, I'm getting the problem.
that's why like I say at the outset that science is a faith in that you believe what's happening will persist in the future, and you can say that you can believe the opposite, that what you observe today will not persist in the future. That's another's faith, and or go to the opposite. You can say that, I mean, whatever you observe, whether you observe zero will persist in the future as zero, or you can have a faith that whether you observe as zero will persist, will not persist, will switch to one. That's another faith. So that's why science is a faith. Because you believe that it will persist. That's the point.
Well, and if I could just get back, I mean, I'm just looking at your statement. An object is GRU when, whatever that means, quote, it is green if observed before New Year's Eve and blue afterwards. So until you have both of those things, it's not GRU.
But you have no idea, John, before the fact. And
Well, I know,
let
but I
me tell
mean,
you where the big problem is.
but the very definition of
Yeah,
GRU says green before and blue afterward.
I see. The
Yeah, well,
choice
the
of
thing is,
green.
I think,
Sorry, Hansen, go ahead.
okay, I think the statement isn't very clear, but I get what the authors or whatever Goodman is trying to get at, induction problem. I have never seen this statement before. I don't know what Goodman's induction problem is, but I think I can't surmise, I can see what he's trying to get at, but it's not a logic problem. If you to define a problem, define an object as GRU, you have to wait till after New Year's Eve to define it. But the question here is to predict what it's going to do after New Year's Eve 2025, and
Here's
right? Or am I wrong?
no, you're absolutely. And here's where the real problem is. Because we've been hiding behind semantics all day. If you notice, with the Raven problem, there was a lot of that.
Yeah, because I just came in, but I think that's also not a very well stated logical statement. The not yeah there is a little. I think that's what you refer to as semantic problem. And so previously, prior, the underlying prior is that whatever you observe now will persist in the future. That is actually the premise of science. And so, but you can equally assert your belief that it will turn to something else, the opposite in the future. And that's also a faith. But the two faiths are equivalent. And so you choose one to be science. You choose one, the first one, that persistence to be science, but that's just faith. There's no whatever, yeah.
Here's the issue. The choice of having the property green, and then the difficulty John and probably many others as well are facing, accepting this GRU definition. It depends on time, dude. What kind of definition is that, right? Like what is it? You created something fake, and now you're kind of criticizing science with it. Like, what is this? It's completely an arbitrary choice to have green and blue. So green stays forever and blue stays forever. That's arbitrary. If I had in my language initially in a parallel universe, if I had the properties GRU and bleen, so I have GRU, it changes from green to blue, and bleen that changes from blue to green. Then I can use those to define green and blue relative to time. So it's a matter of complete arbitrary choice. Whether you live in the universe that has green and blue forever, and then you define GRU with it, or you live in the universe that has bleen and glue, right? And then you use to define green and blue. Completely arbitrary choice. We just happen to choose the world where green and blue are the standard go-to. So if I were to rephrase that problem in a different universe, green will be the odd word. It's like, what? Green depends on time? What are you talking about? I don't want that. No, give me GRU. I know GRU. I'm comfortable with GRU. So that's the real problem here, that I cannot escape easily. That it's an arbitrary choice. If you're not happy with GRU, it's an arbitrary choice that we are happy with green. And then this means that until time t happens, I have no way to distinguish between something that is green forever and GRU, because induction justifies both equally. The premise that says this emerald, this weird object, will stay green forever, and the other premise that says this emerald will change color after time t. Since time t hasn't happened yet, the piece of emerald I have in my hand is both, 100% equally valid evidence for both.
Well, so I mean, I guess I would just say, I mean, I think there's just all sorts of, as we've already established, there's just semantic problems. But I don't have any trouble with the definition of GRU as long as it's something that we understand. We simply can't tell. I mean, an object that was green before and was blue afterwards, is properly a GRU object, right? I can't look at an object and tell that it's GRU, but I can determine whether an object is GRU after New Year's.
That's the problem. That time t, it could be any time. I chose New Year's Eve this year. It could be next year. Could be 20 years from now. Could be the next minute. We have no idea.
Yeah, okay. But I see. But that seems to me like somehow that's kind of a second order thing. I mean, if I just said after New Year 2024, does that solve the problem and now we're completely happy?
Well, if you say 2024, it's already done. So you can say, yeah, the things that have changed color and we remember them, that's another problem. Now you're going back to the past. Do you rely on your memory, right? But let's accept that. Then you can say, oh, we've determined they are GRU, and we've determined that they are green. Now I can ask you again, that blue thing that you have, you've seen it, that it was green and it has turned into blue. This New Year's, will it stay blue or will it turn back?
Doesn't matter.
It does. Kind of does.
I see what you're saying. See, because I said it was if it was green. I mean, once again, this just all seems like semantics, but it was green before
It
New
is.
Year's 2024, and it was blue afterwards, but not forever afterwards, just afterwards.
This is the problem. This is the problem with induction.
Well,
Right? This is
I
exactly
guess
the
I'm
problem.
just seeing it as as a problem only with semantics. I'm still not sure I understand how
Oh,
it's a
come on.
problem with induction.
Even the Hample one?
The Hample
Forget
one I
about this
get.
one.
The
This one,
Hample
you're
one
not
I get.
convinced because you want to be minimalist, and you're gonna be like, you know what? I'm gonna wait until time t, which you don't know, by the way. You have no idea beforehand. So you will just wake up
Well, I
one day
just
and it will
wonder if
change.
there's is this the I can't remember whose this was. I'm not looking at it now. Is this the problem that we're looking at now is a problem that does always have the time thing in it? Is that because the Hample thing I get, that one I'm
Yeah. So this one is
compelled by. I don't find this one
induction.
compelling somehow.
You
Goodman.
don't
I don't
find it
find this
compelling.
particular
I beg to
example
differ. I think
compelling.
this one is much more dangerous.
Maybe that's because I don't find it compelling, right? That'd be pretty dangerous if it should be.
It's not about finding it compelling or not. Let's revisit the premise of induction. The premise of induction says when you make enough observation of the past, you should be able to have enough information to predict the future. And this is what we do every time we build a building, every time we send a rocket to space, every time you take a pill to heal your headache. Because you've made enough observations in the past, you are predicting the future with it. Now, this is Hume's problem. Goodman's problem says you have no idea not only but what will happen in the future, but you cannot tell the difference between properties that you have access to, properties that you have names for, and the properties you don't have names for yet. You're just ignorant here, and whatever observation you're making could be interpreted in many, many different ways because the future hasn't happened yet. Is this version better, John? I'm not sure. I'm trying my best. Anyone else, by the way? This is the last thing we're going to talk about today. So the floor is open for all your questions. Probably we're going to make a quick summary and then let's have, let's say, 10, 15 minutes of discussion. But about this first, if the Goodman problem is clear, and about anything else, if you want.
Hi, can I ask you a question?
Of course, bro. Hey.
Hi. Could you please again repeat the basic assumption regarding the induction logic?
The basic premise of induction.
Mm-hmm.
Making enough observation in the past, observing the same thing again and again, informs what will happen in the future. I can predict based on past experience what will happen in the future.
Yeah. And then you said that the making a prediction in the future does not always guarantee what you get as an expected result in the past, right? That's
No,
what you're trying to
there's
say?
absolutely no basis to believe that. And we started by naming 4 different answers for this. And the 4 answers, if you were with us, turned out to have problems with them.
So you said that there is no absolute basis about the future prediction, right?
There shouldn't be. No.
Yeah, there shouldn't be. Okay. Then when you make that conclusion, so you already make another assumption that the reality is changing, right?
I'm not making any. I'm just saying we don't know. This is the basis of induction. And induction is this move that we always make in science. We even make a worse move, by the way. We make abductive reasoning. So we apply it to the best answer, let's say, or the one that is more likely to us, which is even a bigger problem. But if there's a problem with that, then every scientific claim we have, it became immediately the same thing as superstition. So far.
Could you please let's dissect every sentence that you are making a claim. then what you said is that um, uh, so when I tell you that, so when you make that conclusion again, then I tell you that then you are again making a prior assumption that the reality is changing, and then you said that no, I don't know. Then if you don't know, then how do you again come up with that conclusion? Do you know what I mean?
Science is the one making the claim. Science makes the claim, or let's say not science. Sorry, let's track back. Inductive logic makes the claim. Inductive method of knowing
yes,
makes the claim.
In general,
It
yes,
says
I do.
if you make enough observation in the past,
I do. Yes,
then
I do. I work as a scientist, so I know that. So let's focus on science. And so you said that, yes, I do understand what you are saying, that science is based on the inductive reasoning. Yes, I understand what you mean. So let's focus on science. So we make observation, we do experiment, and then so we assume that the reality is, let's say, more or less fixed. So we do experiment on, let's say, mice, and then we go further up on other higher primates, and then finally on the humans. So the basic assumption that we make is that the something that is fixed or more or less fixed is the evolution. So, but what you are saying is that what you make is what you trying to find as a conclusion in the mice, that it's not always certain in the macaques or in the primates or in the higher primates like humans. I do understand, but what you are saying is that it's completely what I'm trying to understand you is that what we make as a conclusion in the mice has nothing to do with what we get in the mouse or in the
yes,
humans.
absolutely. What we have observed in the past about mice should have no implication whatsoever on the future of mice. So if I see a mouse jump 1,000 times because we electrocute it, making the assumption that it will do the same thing again, we tried 4 different ways to justify this, and it didn't work.
I beg to differ to you, and that's a big claim.
Wait,
and big claim requires big evidence. That's it.
You've already said it yourself from the very beginning. You said you assume it's going to be fixed, right? That says it all. Nothing needs to be discussed any further. You said you assume it's fixed, right? That's it.
Yeah, it's based on the assumption.
Exactly. So why do you take that assumption? Why do you pick that
But
assumption?
that assumption is also based on the evidence.
Well,
We have got the evidence.
No, that's a priori.
That
No, that's a priori that you assumed. But you can assume the opposite, that anything will change. What you observe will change to something else. You can also assume that, right? That you picked the fixed assumption arbitrarily. That's the point.
not arbitrarily. I mean, how evolution is. We assume that the evolution is more or less fixed or constant.
Well, you did assume that. You assume something is going to be fixed, right? You're trying to find that something.
I mean, if you go to
fixed.
then I think now you are trying to go to the Platonic truths. Then yes, I'm not a mathematician by profession. I'm a neuroscientist by profession. But if you really try to go to the deeper level, then I think you have to go to the axiom, and then maybe if you go to the axiom, then
say again.
Axiom. Then the axiom. Then
axiom,
maybe
I think you said.
axiom. Then you have to go to the
axiom.
element of
axiom.
Yes, and the Euclid first. I think, as far as I know, Euclid is the first one who quantitatively defined axiom as a self-evident truth.
Well, so axiom is something that you choose.
That's what I'm saying. According to Euclid, axiom is defined as a self-evident truth. For instance, he defined as a point, and there is a big debate between Pythagoras, Plato, and Aristotle. So if you
well,
want to go to the basic truth, then maybe we can discuss about the basic
the axiom
axioms.
is not it's self-evident is something it doesn't say anything. You can assume anything. You can set up an
Then how do you
axiom
define?
any way you
Then
want.
how do you define a point? That's the
Well,
basic.
it's just a concept. It doesn't have
Hold
to be.
up. We're kind of digressing here, guys. How do you define a
Exactly.
point is way beyond what we're doing here. What we're doing here is way simpler than this.
But it's simply a point can be anything, right? So it doesn't matter.
We don't even need points. So you can have Euclidean geometry with first order logic, which uses congruence and betweenness as properties. You don't need points. You just need vague objects. Call them A, B, C,
Yeah,
whatever.
exactly. I mean, that's my point. That's my point.
That's your point. That's my point as well.
Okay, yeah, exactly. Yeah, I mean,
so you
a
assume that
can
science
be a
is
point
based on faith.
in a functional space.
I'm not pro. Let's make something clear. I'm a scientist myself as well. I'm a mathematician. I'm not a scientist, but I was trained scientifically, and I'm not trying to attack science here. What we're trying to do is to explore the foundations and the basic assumptions that we make whenever, the audience is also very well trained scientifically. Everyone here, we're friends. None of us is like a spiritual someone in the Amazon, trying to preach that touching the ground will get you rid of negative ions, which is good for you. We're not those kind of beliefs. I'm just trying to ask the question: what is it that sets science apart? So why is this not a good way of thinking? And why can we not access that conclusion? Why does science claim that this conclusion is not accessible, let's say, by induction? Whereas, the other conclusions, science prefers them. There's like, oh yeah, this is a nice experiment that reveals the Higgs boson. And now we know, like the Higgs boson gives particles their mass, or some of particles at least. You know what I mean? Like, what's the difference between that and slaying a goat every day so that it rains? From the point of view of induction only, it looks like they are the same. Of course, there's much more details. Of course, there's added things that you can do. Wissam in chat is making excellent comments all the way. He's trying to open new windows for people. You know what I mean? So I'm not saying science is only about induction. I'm just saying if you take induction face value the way it is stated by most people, you get very big problems. That's all I'm trying to show here.
It's the one thing I've really kind of come to in Clubhouse is really recognizing that all my worldview is built almost entirely on my belief that there is an objective reality that we'll never know. We'll never know what it is, but it's the thing ultimately that grounds everything we do, including the fact that we can walk across the floor. We stand up, we know that if we push backwards on the floor, we'll go forward. And that's because there's an objective reality that we summarize in Newton's third law, if you want, or whatever. And those laws, are fixed. Why are they laws? Don't know why the world works like that.
And today was about why they are fixed, by the way. Because we need to assume they are fixed, because if you don't, then science cannot move forward. Every time I have to do an experiment, I have to do the check of every 501 of those laws just to make sure that it's still the same. And even when I'm done, but some time has passed, we got to do it again.
That's
so
right.
this is a basic assumption that
Well, I was just gonna say, and ultimately, I'm really happy with my faith because it's so abundantly borne out simply by the fact that science works. My faith in the in the existence of an objective reality is confirmed every time I see science working.
Yeah,
it's a gamble. It's a gamble.
That's true.
But then, John, what's the difference between you and someone who believes in horoscopes?
Well, I think
for them every time they read the horoscope, they find out that it happens. And it's your explanation that says, oh, it's a self-fulfilling prophecy, or it's your own opinion, or it's your own whatever. But from their perspective, that thing has a causal effect on their lives. because by induction, this is what they've seen so many times now, that every time they read the horoscope, it's 100% the case. And even when they don't read the horoscope and read it, in retrospect, they're like, oh, I should have read it because I should have known that I'm gonna do 1, 2, 3, but I don't. And if you want to hold on Karl Popper, if you want to hold on Karl Popper for me and say, oh, but the claims that horoscopes makes are not falsifiable, then I have good news for you. We will talk about Karl Popper at some point.
Well, I think I guess I was just going to say, I think they are falsifiable and are indeed falsified. If we did any kind of a real study, we would find out that, that they're not either, well, they can only be not falsifiable to the extent that they don't say anything, but they do say things, and you can check, do those things come true? On even the vaguest of those things, if they say anything that's even vaguely quantifiable, you'll just find out that they aren't always true. I mean, I think there really is a difference, and that difference can be measured.
Wissam in chat is having fun. He says, if you believe in the Big Bang as a matter of fact, with all the details, you have enough faith to move mountains.
I agree with that too. I mean, I think that's
Totally.
really true. Yeah, that's
Well,
really
so
true.
I'm struck that there's a saying that I've heard from different people. That's like when you're proposing a new theory, you're allowed one miracle. Like Big Bang seems like that. Like, hey, maybe we all came from a Big Bang. Like, well, that's a frickin' miracle if there ever is one, right? But like what you do after that, I guess is what science does. It's like, well, like if you look at the physics of the early Earth, the early universe, like they got this shit dialed in, right? Like, but the actual idea that we started in a Big Bang, like that's absolutely an article of faith. But then you can follow that up with all this math and all this, like, well, if if it happened this way, then this is how things would proceed, and and it starts matching all these observations we make. So it seems like, you know, I 100% agree that science is based on faith, but it's like it starts with a tenet of faith, but then you proceed very differently than how religion proceeds. It's all the steps after that, um, that are handled differently. I think.
You're right. This is an opinion in the theory. It's called hypothetical deductivism. Well, I'm kind of making a leap here. I'm assuming that you hold that point of view because of what you said. So basically, premises in science are judged not only based on the logic and their deriving and all that stuff, but they are judged based on the observation and their entailments. Their entailments in the world, right? So this is called hypothetical deductivism, and we kind of touched on it today when we mentioned Hample and the problem with the ravens. Seeing a white shoe all of a sudden now is proof that ravens are black. There's a very similar issue with this that maybe I should have a room on this. I'm not even sure actually how to proceed after this point. I got to sit down and think. But yes, even their hero. And I'm like you as well. I think like this. Like, yeah, of course, science is kind of different. But we will discover that the same trick that we did with Hample, a very similar one could be used to negate this one. And in due time, we will come back to that discussion.
Do we? I hate to mention this 2 hours plus into this conversation, but did we ever really talk about what you mean by faith?
Oh yes, in the very first slide. If you are with me on Jitsi,
I might have missed it. I'm sorry. I apologize.
I'm gonna of course I defined
Okay, so
it. And the very first slide, it says, slide number 2. This is not something that has to do with religions. I defined belief by saying this is the attitude of accepting a premise, or some other people take it further. They say behaving in the acceptance of that premise. Whichever one you want, I'm really not bothered. I'm happy with the attitude of accepting, actually. And faith will be believing that premise without providing any, or between parentheses, sufficient, question mark, because you define what is sufficient for you. This is predisposed, and before we start, this is part of your quote unquote axioms or initial suppositions or definitions. You say, oh, a premise is taken for granted when, and you tell me your derivation rules. And so again, we go back to when we said last time about this kind of internal justification school. I can't force people to say this is sufficient, this is not. It's ultimately the choice before we start. If I accept the premises, then yes, sure, but you cannot force me to accept the premise. And so it's a question mark. But whichever one you want, right? Whichever one you want, when it falls short of that criteria, and you still accept it, you still believe it, this is faith. I'm in my mind, this is fine. I'm not sure if you agree with this or not. Of course, we can discuss.
Well, I'm always struck by this book by Alan Watts, where he talks about. He says the thing that it's almost the opposite of what most people say, but I really like it. I'm always curious to hear what people think about it. But he says that belief is like a clinging to an idea, an insistence on an idea, where faith is like an open acceptance of an idea. And he says that, like, because of that, faith is like the essential quality of science, and any true religion. He basically thinks belief is like the bad thing, in like a Buddhist sense of like a clinging to something. Um, I don't know I don't know if that's just like a purpose reversal
I don't know
of
either,
meanings of
man.
things, but I still like it.
The Christian kind of attitude to this is, faith is a positive call for action. So the devil is a believer in God. The devil knows 100% that God exists and knows all the stories. So being a believer in the Christian mind is not enough. You have to have faith, because faith is called for action. I don't know. Whatever. Yeah, sure. Okay.
Well, science does seem to embrace an attitude of non-belief, right? Of not like insisting on things be true, simply following the evidence and being open to what the truth is. So whatever you call that. But I think using the word faith in a discussion like this is sort of being a little button pushy, because it's kind of a bad word to most sciencey people. I don't think it is, but
I mean, I'm allowed to be a little clickbaity,
yeah, no, it's totally fine. It's totally fine with me. But I think it is
just a
fun to
tiny bit, though.
challenge
Just a tiny bit.
just a little bit. Yeah, got to get people in the room.
Just a tiny little bit. I'm not very far. If you take my definition, I'm not far. The definition I proposed is very fair.
Well, yeah, I mean, like, I think I agree with John. Like believing that reality exists independent of me, like just personalize it, like before and after I'm around, reality is going to be the same. I'm not significantly changing reality. That doesn't seem like a huge, leap of faith. That seems like a very reasonable stance. But you do have to take I guess, an additional step to sort of believe that the universe is not like, it's not a trickster universe. It's not trying to fool us. There's no.
Oh, that doesn't have to be a trickster universe. It can just be a random universe. It changes all the time. Why would it be the same thing? You know what really strikes me? These believers who always argue. I'm not a believer. I'm an atheist. I used to be a believer, though, and I only discovered this when I left the faith. The most convincing piece of evidence, let's say, or argument for the existence of God, I can't call it a piece of evidence, is this uniformity principle that Hume talks about. I wish believers argued from that point. You know what they use? Aquinas's 5 arguments, argument from design, argument from whatever. All of these are much weaker than this point. The fact that we live in a universe so orderly, by what meaning? Not only that it was designed for us, right? That's easily, not falsified, but it's easily refuted. But the fact that it is stable, like the most miniature thing in this universe that you discover applies not only here, but if you even go to space, to a very far place, we believe it applies. And we're using this information, we're observing radiation that comes to us from billions of years old in the past, and we're going to say, oh, it's redshifted. What do you mean redshifted? Oh, it's radiation. It acts exactly like the same one here on Earth. Absolutely, and it works. And it works wonderfully. And for me, this is absolutely mind-blowing. Why would it stay the same?
This is called fine-tuning to them. They all use it all the time.
That's not fine-tuning. Fine-tuning says, oh, if we come a little bit closer to the sun or a little bit further away from the sun, we would have burned and life wouldn't exist. Oh, look at the bee. Oh, what a wonderful creature. It collects the pollen, and then the pollen falls from the body of the bee onto the other flower, and it pollinates it. And oh, how wonderful this universe! Look how wonderfully, everything falls into place. And all of this is so that us human beings can look and marvel at the splendid, creation of this wonderful, wise, and infinitely clever creator. This is kind of the fine-tuning. I'm not saying fine-tuning.
This is true.
There's different levels of fine-tuning, right?
Yeah. I'm not. Yeah.
There's like
if you want to call it that.
Our planet. If our planet was slightly different, then we would simply have evolved slightly differently. But there's also like fine-tuning of the universe, right? Like if the fine structure constant was some digit out at the 24th decimal place different, then the universe would have collapsed in a billionth of a second or something like that. That's a different kind of fine-tuning, and scientists.
But that's easy. But that's easily refuted, Hero. That's easily refuted. You can say the other universe existed and then they collapsed, and so we are in the one that doesn't collapse. You know what I mean?
That's an incredible statement of faith too. That scientists have felt compelled to conjecture the existence of an infinite number of universes to explain our universe. But
we haven't. We just said we happen to be in this one. It's a statistics. We only see this one.
Right? I'm not a theist, but I wish atheistic scientists would sort of admit that's astonishing that scientists feel the need to conjecture the existence of an infinite number of universes that we have
we're not
that we have zero observational evidence for.
I'm personally not making that.
No, but people are, like serious people are.
Maybe.
Yeah, I just wish people would appreciate that a little more because it's true.
Yeah, I think when you look at the anthropic principle, it takes kind of two forms, right? Yeah, it's a miracle, right? The one universe that there is so fine-tuned that life, intelligent life can exist. That's that's one form of it. And you just say, well, of course we wouldn't be here to observe it if it weren't. So yeah, it's kind of amazing, but so what? And then there's the other form, which is what Andy's saying, where you just say, well, of course, there's an infinite number of universes and we're in the ones that allow us to be. It makes it a little easier to accept that idea, but it can take both forms. It does tend to take the form, I think, in most people's minds that Andy is talking about.
It's a lot of work to do to avoid being impressed with the universe we live in.
Yeah, that's right.
I'll just take being impressed. I just think I'm gonna have to believe in God, but I'm still impressed. Like, why do we have to pretend like we're not surprised?
We are, but the thing that surprises me is not how precisely fixed it is. That is surprising as well. But there's even a much more surprising one for me, is that it stays the same. You leave a cup here on the table today, and you go to sleep, and tomorrow you see the cup exactly the same as it was. Why? In a random universe, because we have no idea how our universe started. In a universe that started from chaos and all these violent events of the Big Bang and everything that followed, you would expect that things would go rogue. You would think that things will disappear and appear out of existence all the time, which kind of happens on the quantum level, and as far as I understand. But with macro-sized objects, it never happens. In fact, we put each other in jail because we find something that was your property in a crime scene. It's that good, this thing. It never fails. Any other thing, people? So yeah, today we weren't talking about nature, by the way. We were talking about the problem of induction in science. How is it that observing something in the past affects, or we believe when we are doing science, affects future observation. So we kind of have these expectations now that it will hold into the future. We talked about all the different problems that this has, namely the Goodman problem of induction and Hample's problem of induction. And essentially, we started with Hume, of course, who is the first one to formalize the problem. we also talked about 4 different answers for this. The first answer is kind of an answer that says, oh, the definition of rationality is induction. Yeah, right. That doesn't work. The second answer is, oh, induction works because it works. So because it worked in the past, it will work in the future. Yeah, that's circular reasoning. That doesn't work. And we talked about the probability approach as well. And we kind of explored where that probability approach has also problems. When we explained the little bit of logic, and then we saw that when we have 2 equivalent statements, evidence for one should be evidence for the other, but then the other is completely a ridiculous construction. This is what we were talking about today. I wanna see if there's anyone who has questions about this. We're kind of heading towards closing the room down. Yeah.
Well, that was pity. I was not in this conversation from the beginning.
Oh, don't be sad at all, because all of those will be uploaded to our YouTube channel at the Scientific Discourse, where my dear friend, where is he? John, is he still here? Yes, Dark John is still here. He runs rooms every Friday as well. So we have our Philosophy Wednesdays every Wednesday at 17:30 GMT, and at the same time, 17:30 GMT. John Mallinckrodt, a professor, retired professor of physics, he runs his Bites of Physics rooms, which are becoming very, very popular. John, do you have any idea what the room next Friday will be about? This Friday, I mean, 2 days from now.
Yeah, we're going to talk about Einstein solids as a way to get to the definition of temperature. Interacting systems. We need a model for thermally interacting systems so that we can understand the idea of temperature. And we'll get there next week. So that's kind of the next 2 weeks.
The next 2 weeks. So this Friday and the Friday that follows. So you can find John by giving him a follow here, of course, and by joining the Scientific Discourse house on Clubhouse. I'm gonna ping a link in the chat in a minute. You can also find all the past lectures, not all of them. I'm still working on posting them, but bit by bit we will start posting the old lectures also with their slides on the Scientific Discourse YouTube, so that you can refer to them whenever you need to. All right, thank you very much. We have reached the point where I thank every single one of you for being here. Of course, old friends, John Mallinckrodt, absolutely, even though your phone gave you trouble, you managed to be here. Thank you so very much for being here. Hero, Hansen, long time no seen. Dr. Lubna, same thing. Wissam for being here from the beginning in chat. Everyone else, thank you guys so very much. Take care. Bye-bye.